Math over here, and this is the 2004 AIME 1 problem 7. Let's have a view of this problem. Let C be the coefficient of x squared in the expansion of the product 1 minus x, 1 plus 2x, 1 minus 3x, all the way to 1 plus 14x, 1 minus 15x. Where in general, we see that the odd x coefficients have negatives and the even x coefficients have positives. And we want to find the absolute value of C, where we call that C is the coefficient of x squared. So I'm going to actually write this polynomial down over here. Great. And then what we notice is that to get the coefficient of x squared, we need to consider first the set of coefficients of our polynomial, meaning that we have, let's see, -1, 2, -3. Let's just consider all the set of the coefficients in the factored form. And then we see pretty intuitively that to get the coefficient of x squared is just simply the pairwise product, right? Negative sum of the pairwise products, -1 times 2, -1 times -3, all the way until -1 times -15, go on to 2, 2 times -3, 2 times 4, so on, so on, so on. And then it should immediately jump out to you that this thing is like extremely similar to like what we do in like Vieta, right? For example, consider the expansion a1, or I should say more for like factorizations, plus an squared. What is this equal to? This is just the AI's, all the AI squareds, all the a sub I squares, and then plus 2, and then we can actually write this more compactly. Instead of just a thing, we can write it as summation. Let's see, 1 I less than j less than or equal to n of a sub I, a sub j, right? And this is basically just a generalization of this factorization. So let's actually plug that in and we really want to find this, so let's just plug in the information. So we have what, 15 terms over here. We have, let's first just find -1 plus 2 minus 3 plus 14 minus 15. Couple ways to go about this. Let's see what's way I'm going to do it. I'm just going to pair it as follows. Pair the odd terms. 1 plus 3 plus 5, 7, 9, 11, 13, all the way until 15. And then plus 2 plus 4 plus 6, all the way until 14. 1 second, 14. Does this look good? Okay, yeah, this looks perfectly good. And then, okay, formula for arithmetic sequences. And how many terms are in this one? The function that generates this term is -1 plus 2n, so there are 8 terms in this. So a sub n by 2 times 2 sub 2a sub 1 plus n minus 1, 7 times common ratio. 16, right? You have 16, 64, put a negative sign, this sums to -64. Let's deal with the sequence now. There are 7 terms, so 7 by 2 times 2 sub a sub 1 plus n minus 1, 6 plus 12. This becomes 16, 8, this is 56, right? So, okay, so we do -64 plus 56. This gives us -8. And then we need to square it right over here. Square it to get 64 is equal to, now we need to take the sum of the squares of the individual terms. That's just 1 squared plus 2 squared plus 3 squared, and then so on until 14. My pen is a little bit bugging out. 15 squared, right? And then we'll just apply the formula for n squared, and I suggest that you try to prove it using induction if you have the time. So 15 times 16 times 31 over 6, right? N times 2n plus 1. N times n plus 1 times 2n plus 1 over 6. This looks good. Okay, this cancel this. 2 with 5, 1 with 8 to get 40 times 31 Okay, this is equal to 1240, right? Yep, 1240. Am I doing this right? Yeah, it looks good so far. So I summed these two to get negative 864 is equal to 1240 plus 2. You know what? I'm not gonna write this thing. I'm literally just gonna call it our desired expression, desired. So let's just do the math to get our desired. 64 minus 1240 is 936, 1176, right? Yeah, so negative 1176 is equal to 2 times desired. Hence our desired will simply be equal to negative 1176 divided by 2, which is 570, 580, negative 588. So we found the coefficient of x squared over here. We want to find the absolute value of the coefficient, so therefore it's 588. And we are done.